So, today going to finish up the series I was doing on interstellar travel. And we are going to be talking, like I said last time, about wormholes. Now then, around 1915 I believe it was, Einstein published his theory of relativity. He had a few unsolved equations in it. That same year, or later that same year, a man named Karl Schwarzschild, a German physicist, solved some of his equations. Field, relativity field theory is what they were. They were open equations. Next year, 2016, a Austrian physicist named Ludwig Flamm postulated the ability to. He postulated the concept of a white hole. Now, relativity had already predicted black holes, interstellar phenomena which absorb a lot of, basically suck stuff in. Gravity sucks stuff in. And so he postulated that there might be something called a white hole which spits stuff out, and the possibility that there was some sort of time-space tunnel between them. This has since, you still every now and then hear people mention white holes, but it's really not accepted anymore. But that was the first quote-unquote wormhole, although it wasn't called a wormhole at the time. And a while later, 1935, Einstein and another physicist named Nathan Rosen finished doing some calculations, basically, to show mathematically that such a structure could exist. So relativity didn't prove their existence of and by itself, but they calculated that yes, this could really exist in the real world. Now we jump forward to 1957, I believe it was. Let me check my notes. Yes, 1957. And a man called John Wheeler made reference to this and referred to it as a wormhole in space. And so we now have a name given to the phenomena. Well, the more common name given to the phenomenon. Anyone who watched the Thor movie knows that the Bifrost Bridge was referred to as an Einstein-Rosen bridge, because that's sort of what they were calling it at the time. But Wheeler made popular the term, or he coined the term wormhole, and it became popular after that. 1985, Carl Sagan's writing a book, Contact. Well, he published a book, Contact, at least. He was writing it earlier. A man named Kip Thorne, another physicist, basically Sagan was talking to him and said, I need a way for people to travel vast distances in a short amount of time. And Kip Thorne said, well, what about this thing called a wormhole that Wheeler coined based on Einstein and Rosen's theories? And so wormholes became popular in science fiction after that. They had existed prior to that. 1974, a man named John Haldeman wrote The Forever War, in which he basically was using Ludwig Flamm's theory, only instead of a white hole, he was using basically two black holes with a tunnel between them. This was before people stopped believing that this was a possibility. And even before that, 1931, so even before Einstein and Rosen completed their equations that showed that the wormholes could exist, a man named, what was his name? Jack Williamson wrote a short story called The Meteor Girl, where a guy used his knowledge of relativity to create a rip in time and space and rescue his fiancée. So wormholes popularized, most of us would have never heard of them if it weren't for science fiction. And so I'm going to talk about, as my final installment on interstellar travel, how well would wormholes work for interstellar travel? Now, personally, I don't like them. This is largely because, see, back when, the earliest explanation most people get is we got a point here and a point here, and we want to get from one to the other, and a wormhole is sort of like you bend space, and now instead of being far apart, they're close together. And what I don't like about that explanation is we're talking about an almost two-dimensional object here. Bending it, rolling it up, all that other stuff. It looks lovely, it's a great demonstration, but it just doesn't seem plausible. It's, the universe as we know it is either 3 or 4 dimensions if you want to talk about space or space-time. And the idea of folding multiple dimensions like that, it's hard to grasp. So, 3 dimensions. We can bend it. Yay. Okay, now we got things like we're stretching this part, we're squishing this part in the middle here. So our wormhole, it's not just affecting the 2 spots we're trying to get to, it's like twisting space and time all around it. And so there's a little questionable in my mind is, if we did open a wormhole, would it how far and wide would its effects reach? Just because we aren't just bending time and affecting the entry and exit points, we are affecting everything around it. My other problem with this is, even though this is a 3-dimensional piece of foam rubber, it is also still basically, it's got a flat side to it. It's relatively flat, so it is foldable easily. If we took a large cube of foam rubber on about this scale, we could still squish it and twist it and do all sorts of stuff with it, but it becomes a lot more obvious that we're affecting more than just the entry and exit points of the wormhole if we do that. So, like that's my biggest hang up on wormholes is the demonstrations of it. We're trying to explain how to fold 4-dimensional space by folding a piece of paper, which is very close to 2-dimensional. So that said, the whole concept is a little out there, and I understand. Yes, it's mathematically it works out, but and maybe mathematically maybe they do exist somewhere in the universe, but the idea that we can use the math to create them on our own, it's just a little hard to believe, just because we are folding space, which again, as a 3-dimensional person, it's hard for me to imagine folding 3-dimensional space. Someone who lived outside our universe or looked in from a higher dimension, if such a thing exists, would have no problem with it, maybe. But I have problems with it. Now, one website, while I was looking stuff up on black holes, or not black holes, wormholes, it suggested, it compared them to black holes in that while we can't directly observe them, we know they exist. And I disagree with that. We have no reason to believe they exist. Now, the site said, they show up so often in our computations. And again, our computations are actually looking for them. So they are a mathematical possibility, yes. Do they actually exist? It's possible, but we have no proof. And just, saying because it's a possibility doesn't necessarily mean it's working. Now, again, I had mentioned black holes several times, some by accident, some on purpose, and how relativity had predicted them. And that, to some extent, that's why we get into stuff like, is a wormhole a tunnel between two black holes? Which some people, played around with that idea for a while. Again, because so much of the science between the two are similar. Not necessarily related, but similar. Um, which brings us to all sorts of other questions. So we're talking folding space. Now, so we take our foam rubber, we draw a line across it, then we put an object on it and bend into it, and our line will bend with the object. And that's one thing people, when they talk about relativity, they'll give this demonstration about how a heavy object will cause a sheet to bend in, and that's sort of what we're looking at when we talk about relativity. And the heavier the object, the more it bends. And again, how accurate is that? Like I said, that's maybe very accurate. I don't know. I'm not an expert, but that's the way it's usually described by people. And so I've got to raise the question there is when we talk about warping space, it usually involves gravity. Heavy objects, more massive objects causing larger distortions in space. So in order to form one of these bridges, it seems reasonable to suggest that we would need a very large gravity well of some sort. Which is why, like I said, relativity predicted black holes, and it predicts these possibility of these bridges. And so I've just got to wonder, do these bridges, if we were to create one, how much mass would it take? How big of a gravity well would it take? And that being the point, could we safely fly through it now? Would this be a pitcher plant? We can go into it, we can't get out because we have this gravity well. Sort of goes back to the white hole theory, where in this case, I would say a white hole would spit you out into another universe with different laws, just because gravity. Yeah, we go in on one end, we try to go out the other end, unless there are other laws which say gravity repels instead of attracts, it seems like we'd be stuck in there. Dangerous sort of thing. So, again, I don't know all the details of this stuff. I tried looking stuff up. Most of the stuff you find online is written for laymen, which, in this instance, I know a little more about relativity than the average person, but for the most part, I'm still a layman. So, my studies into it didn't go that deep when I was in college, although I did study it a little bit. So, we got this big problem then of just what's in the middle of it. It is predicted that there would be a lot of radiation, just like black holes generate X-rays. They think there would be a lot of radiation in there. They also predict there would be exotic matter in there, which I'm not 100% sure what exotic matter is. It's something that doesn't come up that often. I do know it interacts with normal matter in weird ways, so it's potentially dangerous if we try to fly through a black hole that has exotic matter. Wormhole that has exotic matter in it. I'm going to say black hole a lot when I don't mean it, but I'm sorry about that. Anyway, so there's that problem. There's also the problem, basically, unless it's something that's open all the time, which some people predict, some people don't. Star Trek, Deep Space Nine, they had the wormhole to the Gamma Quadrant, and it had to open and close, and they found ways to trigger it to open and close. Okay, so we got this whole, a tear in the fabric of space-time that's just opening and closing. It sounds to me that's not the sort of thing I want too close to the Earth. Sounds dangerous. So we're going to take it, and we're not going to put it too close to the Earth. We're going to put it far away from the Earth. And for that matter, I don't want it close to any other planet either, just because, the other planets do affect us. Their gravity and stuff affects our orbit sometimes. And so I just don't want one of them accidentally popping out of existence and affecting us. Bad things could happen. So we got the sun, and the Earth's going around, and all the planets are going around, and they they aren't all coplanar, but they're fairly close to the same plane. So we got the plane of orbit. So all the stuff's going around. Let's put our wormhole up here somewhere. That way, it's not interfering with anything, and we don't have to go all the way out to the edge of the solar system to get to it. This is assuming we're creating one, or one already exists out there, and we just haven't discovered it. That's the thing again. Wormholes for space travel. Either we have to discover them, or we have to create them. And I don't think we have the technology to create them. I doubt we will ever have the technology to create them. Personally, call me a killjoy, but that's just the way we're going. I doubt it. Okay, so we got that problem. We are again tearing open a rip in space and time. The exit is, I don't know. Like I said, naturally occurring ones, we know enough about relativity that if we study our end of it, we might be able to predict where the other end is just by doing some calculations. I'll accept that. If we were to try to artificially make one, could we do it in such a way where we could control where the outlet is? Maybe. Again, we're getting into technology we don't currently have, so maybe if we develop that technology, we'll have more control over stuff like that. But, again, not holding my breath waiting for it to happen in my lifetime. And then what's happening, like I said, with the foam rubber example, if we're going to be making this bend in space or whatever that allows us to pop through quickly, what is happening to everything around and between it? My example with the foam rubber, and you put a weight on it, and it bends lines around it. That's a fairly localized phenomena. If we're going to try to extract that to where we are creating two of these things on opposite sides of the galaxy or opposite sides of the universe or wherever, then we've got to wonder if the space between, the space where the tunnel would run, I don't know how to describe it because, again, this is a problem. We're stepping outside of the fourth or third dimension when we talk about this stuff, and I can only describe things three-dimensionally. Mathematically, we can predict this stuff in higher dimensions. Trying to build models of them, I mean, we still use paper to describe wormholes. It's not the sort of thing. Like I said, I don't like wormholes. You can't picture them visually. One of the reasons I think it'll be a long time before we even get anything near creating one or manipulating ones if we find them, just because we can write an equation about them at the end. We can't do much more to predict about them or to model them or anything like that. Now, Slipstream. There was a show in the 90s, Andromeda, where they had Slipstream. It was sort of a combination of hyperspace and wormholes. Basically, you were going sort of into another dimension, but there were strings in there. And the thing, your ship somehow latched onto a string and travel along it and pop out into the normal universe again. And we couldn't control the strings, though. So it was basically you were looking for the right one. You had to navigate the slipstream, pop in the right place, grab onto the right string, and hope it takes you where you want to go. That was sort of like I said, a combination of hyperspace and wormholes because you got these strings which are sort of fixed. Fixed paths you can travel along. Sometimes they would relate it as if you were traveling along for a while, then you'd have to pop into real space, travel some, pop back into. So it was almost like, navigating the slipstream, you had to do some of it in real space just because you had to find the right string. And I'm thinking wormholes would work similar to that. We don't have a wormhole like supposing we had personal wormholes. I don't have one that goes from here to London, but I have one that goes from here to New York, and then I can take one from New York to London. It's like transferring airplanes or something like that. Um, I would imagine naturally existing wormholes. That would be the way we'd have to do it. We'd be lucky to find a wormhole close to Earth, but a second one close enough to where we can travel from wormhole to wormhole. Unless that happens, I don't see us using wormholes that often. We'd have the one from Earth that would go to wherever it goes, and that would be it. Again, presumably these things take a lot of gravity, so would they be attracted to each other because of the gravity? In which case, what would happen if two wormholes intersected? So I'm thinking if they do exist, they are very far apart. So, like I said, we find the entrance to one, and it takes us to another one, and that's about it. We can't go from wormhole to wormhole just because I think they would have to be far enough apart that that would be impractical. It would be, in some cases, easier just to try to travel there without them. So that's it. Like I said, wormholes. If you want to go into science fiction where we can just create them at random and do what we want with them and manipulate them, okay, they're good. Real life, I don't think we'll have the technology in our lifetime, or probably maybe not even 10 lifetimes from now. But if we ever do it, it's going to be still, even then, it'll still be tricky. And it would be a long time before we could use it for anything on the scale we would want to get into science fiction. So that's it. That's the end of my interstellar travel talks. This is what I think the fifth or sixth video on interstellar travel. I've been spacing them. Hey, hope you've enjoyed it. Stuff to think about. I like fiction. I have no problem reading about this stuff. I just don't think we're going to spend a lot of money trying to open wormholes just because it's too dangerous for us to handle this stuff. At least right now. So that's it. Have a nice day.